Okay, welcome back. During our break, we have lots of volunteers who have circled around the room and are taking a look at our driving question board. And we have lots of overall themes, I think. And so we'll kind of be addressing those questions throughout the rest of the day. Feel free to revisit your driving question board and add those blue sticky notes. I see a bunch on here already, which is really exciting. So my job now is to introduce our keynote speaker for today, Dr. Terrance Burgess. Dr. Burgess is an assistant professor of science education here at MSU in the teacher education department, where he dedicates his research and expertise to the critical intersection of equity, science education, and identity formation. Committed to fostering equitable learning environments, Dr. Burgess's work includes understanding and enhancing science education opportunities for elementary youth of color in urban settings. He explores how these young individuals navigate and negotiate their identities within the science classroom. Dr. Burgess places an emphasis on amplifying the voices of youth of color, ensuring that their experiences and perspectives shape the discourse around science education. His approach allows for an understanding of how these students come to view themselves as scientists. Today, I challenge us to confront the inequities in elementary science and use this opportunity to take steps forward toward nurturing our youngest students' identities as scientists. I've been working with Dr. Burgess for a couple years, and I'm really excited that you all get to hear from my wonderful colleague. Please welcome Dr. Terrance Burgess.
Thank you. I'm gonna start my timer. All right. All right, so good morning, everyone. Thank you, Corey, so much for the introduction. Hopefully this will advance. Here we are. So again, as Corey mentioned, my name is Terrance Burgess. I'm an assistant professor of science education here at Michigan State. And the title of the talk that I'll be sharing with you all this morning is Science Learning is a Civil Right, Re-envisioning the Possibilities of an Equitable and Just Elementary Science Education. So before we get into that, I know we acknowledged the space that we're on this morning at the beginning of our time together, but I think it's really important for us to just keep that in mind, especially as we're thinking about conversations around equity, specifically thinking about civil rights and thinking about those things in tension with space, specifically the space that we're in right now. All right, so before we get into the meat of the conversation, I'll just have a couple of guiding things for us throughout the course of the talk. So first, I'll start with a couple of questions for us to kind of think about, and then frame what is happening in elementary science instruction, which will be very easy because of the fact that we've done much of that already this morning. And then thinking about equity specifically within science education, and what does that look like in practice? So thinking about the standards specifically that have implications for equity, but thinking about this question of, well, what does this actually look like in a classroom? What does this actually look like in a community? And then I'll conclude with some recommendations for various stakeholders, many of you being those stakeholders that are in the room now, and some parting thoughts for you all. All right, so first, I'm gonna ask, just as we had the science experience this morning and we had the driving question board, I'm gonna have a focus question, or a couple of questions rather. So you will need your phone or a mobile device for this, and there are going to be two questions. The first question is, when you hear the word science, what words come to mind for you? And so you can go to Menti, MENTI.com, and if you enter the code 534-03327, it'll take you to this poll. So as you're doing that, I'll give you a couple or another minute to scan the QR code, and then I'm going to switch screens so that we can see the results as they populate. 534-03327. All right. All right, so it looks like we're at about 130. Right. We'll give it another minute, or 384, I'm sorry. We'll give it another minute. And as we're looking at the words generate, for those of you that are unfamiliar with word clouds, which is the name of this diagram that's being populated, the frequency of the word or words that are being referenced is indicated by size. So the larger the word is on the screen, the more frequently you all are using or entering that word to describe what science or the words that come to mind for you when you think about science. All right? So I want you to, again, think about those words as they're coming up. It looks like curiosity, fun, experiment, explore, discovery. Those are kind of some of the ones that are right at the center of the cloud and the cluster. Okay. So again, keep these words in mind because I'll return to them at the end of the talk. But the next prompt that I'd like for you all to respond to is if you open up that poll, again, I'm gonna advance the slide and you should see this question here. So I have observed at least one science lesson in my building this school year. So you can indicate yes, no. If it doesn't apply to you, you don't have to answer the poll, but a bonus for you if you've observed more than one. So we're setting the bar, unfortunately, low, but we'll talk about why that's the case as well. All right, so it looks like in this space, there are the majority of the room, and I'm gonna assign or assume that's because of the fact that we all have a vested interest in the topic, right? Most of the room has observed more than one lesson, but of course, when we think about if we were to administer this poll in a school or in a district without the stakeholders as you all are in this particular space, we might see that most of the responses are in the no category. And thinking about the students that I work with here at MSU, when we send them out into schools, unfortunately, some of the only times that children receive science is when we have to make it, or we make it a requirement that they teach a lesson. And so just keep that in mind as we continue this conversation. So as we continue in thinking about these two prompts, again, the state of elementary science has already been laid out for us, but I'll just talk about a couple of things. There was a Horizon report that was referenced earlier. And so when we think about that particular report, prior to the COVID-19 pandemic, students were receiving approximately 20 minutes of science instruction per day, and that's on non-consecutive weeks, right? So it may be a week of science instruction, and then a week of social studies, or a week and then a month later we have alternating social studies and science instruction. So that's important because when we think about the fact that now in a post-pandemic space, a lot of the rhetoric has shifted to, quote, learning losses, specifically around literacy and math, right? So what does that mean in terms of where or how science will show up in the curriculum, right? So in thinking about the experience that we all took part in this morning, that is, just as it was mentioned, an example of three-dimensional science instruction, right? However, that's a lot to ask of a teacher who's juggling 4 to 5 other subject areas to be able to feel confident in doing well, right? And there's data to support that, right? So this graph, for those of you that are in the back, is just the graph that shows teachers' confidence in teaching subject content areas. And so for science, for elementary teachers, 31% feel confident or well prepared to teach science, right? So that helps explain, or perhaps is explained by some of the numbers that we see in terms of instructional time or minutes that are allocated to the subject, right? And then when we think about the fact that they need this additional support, when we think about equity specifically, all of this is happening within this discipline that remains white, right? So that is important because of the fact that it brings us to this conversation around equity specifically. But before I get into that, I want to talk about that's what's happening in the classrooms, right? But what happens before teachers get to the classrooms? What are some of the beliefs that teachers have about science before we get into, or before they get into the classroom, right? So our pre-service or future elementary science teachers believe that scientists work in labs, right, that are separate from interactions with other people. They're white men, white identifying men with wild hair, right? So the stereotype, right? And they work alone, right? So why do I mention this? Well, I mention this because of the fact that if these are the beliefs that are being held on to by our future teachers, what does that mean when they're entering into classroom spaces and working with and serving children that do not look like them, right? If I'm holding on to this belief that scientists have this prevailing identity and I don't see that identity in my classroom, what am I to do, right? So that brings us to this urgent need for thinking specifically about equity in science education. And so we're at this critical juncture where we see several things that are happening at once, right? So if anything, these last few years have shown us, one, that science is being denied, or we're in this phase where critical issues that can be better understood through a scientific perspective are being dismissed, right? So there is a cultural side in which we engage to communicate scientific information, right? So thinking about this idea that, again, whose ideas get represented in the stories that we tell, why is that the case, right? Equity in and of itself, when we think about this conversation or this word equity, it doesn't just exist in a vacuum. Science or math for that matter, aren't separate from the world in which we're living, right? They help us explain what's happening, but they don't just exist in this separate space. And so when we have to think about the schools and communities, again, that we are serving, and thinking about the fact that those things, the socio-political context of those communities inform what it is that I'm viewing in the individual classroom or at the individual classroom level. Right, so with that, I have to think about all of these things when I'm thinking about science specifically, but also in thinking about the work that takes. It's also a racialized endeavor, right? So again, thinking about this socio-political context of a community, race, just as there are critiques where why does everything have to do with race? Well, because everything has to do with race. Right? And so learning science in and of itself is a racialized and politicized act, right? We see that in the research, and it has great implications for what can happen within a classroom. It has great implications for who gets to be considered smart or identified as such, right? So when we think about those things, it brings me to this idea, again, that science learning in and of itself is a civil right, right? So in other words, just as we don't question the need for mathematics and literacy to occur within classrooms and within schools, we have to think about science in that same vein, right? So we aren't asking, or we shouldn't be asking a question of why is it that science is being offered as much as why is it that science is at the end of the day for 10 minutes or 20 minutes, right? Who is it that is most impacted by those decisions, right? So I also think that it's very important when we think about using terms and phrases and words that we be precise with what it is that we mean, right? So for me, I'm considering equity specifically to be a commitment. And it's a commitment to making tangible adjustments to educational environments, policies, and so on that do not dignify all children, maintain their sense of belonging, or lead to high quality instruction. So if none of those things are occurring, then we have this system of inequity that's being perpetuated, right? So in thinking about that particular definition of equity specifically, there's also resources. There are also resources for various stakeholders, again, as I mentioned earlier. And one of the reports from the data that we have access to comes from the National Academies of Science, Engineering, and Medicine. So they also take up this notion of equity, and they define it as these 4 approaches, right? So one approach to equity is increasing opportunity and access to high quality science and engineering learning and instruction. Right? A second approach is emphasizing increased achievement, representation, and identification with science and engineering. A third approach is expanding what counts as science and engineering. So again, thinking about which ideas get represented and why is it that those ideas are represented. And then the fourth approach is seeing science and engineering as part of justice movements, right? So not conflating or conflating equity and equality with one another. That isn't what the conversation, that isn't the conversation that we're having. We're thinking about these systemic injustices that are occurring and what is it that's needed to help move folks along at the spaces in which they are, right? So in this particular case, thinking about science, we can use science as a means to advance equity, right? Advance justice, right? So in doing that, again, as I mentioned, there are implications within standards, and the lovely presenters this morning already kind of introduced the NGSS or just this color scheme to you all. But I'm just gonna talk about there was a driving question on the back board that talked about 5th grade specifically and thinking about, well, what could this look like in 5th grade? And so I actually am talking about a 5th grade classroom now, so that's very, very appropriate. So in looking at this particular document, it may be hard to read, but this is referred to as, that text in red is referred to as our performance expectation. And I mentioned that because this particular performance expectation is around a couple of things. One, by the end of 5th grade, children should be able to develop a model to describe a phenomenon that includes the idea that matter is made of particles too small to be seen. So just as you all constructed a model this morning, right, students in 5th grade are expected to do that as it relates to this particular topic, right? So I bring that to you all because of the fact that I'm gonna show what it looks like or what it can look like in practice. So in those models, there should be 2 things that are visible that the child should make visible to the audience, right? So one of them is that there is bulk matter, so observable things within this model. So if I'm looking at water or a solution, the solution in and of itself is perhaps the bulk matter, but the things that are dissolved in solution I can't see, but I need to figure out a way to represent that. So that's the second part. Particles are too small to be seen. Right? So in thinking about what this looks like in a classroom or in practice, there are two groups of students that I work with. And there's this question, we were all working around this question of thinking about what's in our water. So in one particular group, this poster over on the left-hand side of the screen, they were trying to model what nitrates look like in water, dissolved in water, right? So they tested these water samples, and some of the water tested positive to different locations for 10 parts per million of nitrates. So they were tasked with, how is it that I'm supposed to model nitrates in the water? I can't see them, but how do I know that they're in the water? How do I model that? All right, so that's the group on the left. On the right, this particular child was talking about, thinking about dissolving, and specifically dissolving sugar in water, right? So in this particular model, she has this is a shaker over on the right, and sugar is being shaken into this beaker of liquid, right, of water. So she has dots at the top to represent the sugar that has yet to be dissolved. And then once that sugar has become dissolved, right, she has these squiggly lines to indicate that the sugar is there even though I can't see it. And she talks about that over on the left. She says that when you dry this solution or use a microscope, you should be able to see the sugar in the sugar left behind. So there are these two different groups that I'm showing you their thinking around this idea of modeling and modeling particles to be specific. And I would argue that the model over on the right better represents this phenomena or this idea that something is in a solution and I can't quite see it, right? In this particular case, they have dots to represent those particles. Over on the left, they have the chemical formula for nitrates. And so it would be really hard for us to quantify, given how it is in this particular case. I would say that there's 1 unit of nitrate dissolved in the water in both of these test tubes, even though the data or the number says that there are 10. So why do I say that? I say that because of the fact that this on the left, these are college students. And this is a 5th grade performance expectation, right? The individual on the right is a 5th grader. So we see that 5th graders or children in and of themselves have these very complex understandings of the world around them that perhaps aren't necessarily always tapped into or asked about, right? But I mention that because of the fact that these individuals on the left are the folks that are, again, entering into these classrooms, right? If I'm entering into a space where my notion of modeling is different from what it is that I'm expecting to see, whose idea gets represented within that space, right? So in thinking about these standards, I also want to talk about, we always hear these conversations around what can't be done, and rather than focusing on what can't be done, thinking about instructional time or whatever the barriers that currently exist may be, let's look at and think about the things that children can do, have done, and have demonstrated over and over again that they are capable of, right? So one of the things that we think about with regards to children in science is that they have a lot of wonder and excitement about the world and specifically about science. Right? Science happens to be a subject now where students aren't categorized based on levels, right? They aren't categorized based on how well or proficient they are at reading or how proficient they are at math. And so they get the full space to be themselves. They get the full space to take ownership of their learning, right? So in this particular classroom, we were looking at this question of what do seeds need to sprout, right? So on the board, they were telling me all of the things that they know already about seeds. And then they had in green, this text around what is it that I want to know? What is it about seeds that I want to know more about? So one of the things that they wanted to know more about was how long does it take the seed to grow? How long do the roots get? What do they look like inside? Which I start that question because we designed an investigation to help study what does a seed look like on the inside, right? How does a seed or how do seeds become seeds? And which seeds can you eat, right? All of these are very important and relevant questions. So when we designed this investigation, one of the things that I did was provided them a range of seeds, right? They wanted to know what was inside of a seed. So we also, these beans just soaked the beans so that they're softer, and we could split the bean down the middle to see what was on the inside, right? I also have this little seedling because as they were able to see before the bean, the tail of the bean dropped off, they were able to see that the plant in and of itself is what emerged from the inside of that bean. So then going back to this question, right, what do seeds need to germinate? They now have, or to sprout, they now have a more refined understanding of what that particular, or the answer to that particular question is, right? So children also develop claims and to explain scientific phenomena with evidence, right? So going back to this question of what do seeds need to sprout, one of the things that they mentioned was that I know for a fact that seeds need soil. Well, we ended up germinating lettuce seeds in water, and water using sponges, right? So then they got to this space of thinking about, well, I now know that seeds need water for sure. They said that they needed sunlight and no longer needed soil to sprout, because if it doesn't have water, then it will die from dehydration. So I put a star beside sunlight because of the fact that, to me as a teacher, that indicates that there are still some ideas that we need to revisit moving forward, right? And so in this particular case, they were confident about the fact that seeds don't need soil to germinate, right? And they still were thinking about the fact that seeds need sunlight, and perhaps that's because of where we headed next in the lesson. And so children also can use science to raise public awareness about pressing community issues. So that lettuce, those seeds that I showed you on the previous slide, we grew into lettuce plants in the classroom, right? So we grew about 60 bunches of lettuce in the classroom in those little grow boxes. I provided the seeds, so it costs little to nothing. It was $2 and some change for the seeds. And however, when we think about the exact same lettuce in the mire down the street from the school, one bunch of that lettuce is $2.19, right? So if we were to bring, or if children in this particular case, they harvested the lettuce, had a salad bar for lunch, because of the fact that they were taking part in consuming what it was that they spent so much time and energy growing, right? And so in thinking about that, if we were to purchase that same amount of lettuce from the local grocery store, it would have cost about $130 for everyone to have the amount of lettuce that they consumed in the classroom, right? So that raises a question, and a question that I think is particularly important in terms of thinking about community issues, right? So in this particular case, thinking specifically around food insecurity. All right, so what does it mean for us to think about these topics, again, within the scope of an elementary classroom? These are their experiences, right? These are their lives, and thinking about the fact that, hey, why can I grow lettuce in the classroom, but I can't necessarily pick it up at the grocery store in the same way, right? So then another thing that comes up is thinking about the fact that we can leverage multiple disciplines. So this conversation doesn't just start and stop with science. It starts and stops with all of the subject areas that teachers are expected to teach, right? So in this particular case, I pulled a social studies standard from at the same grade band, And this particular social studies standard is state an issue as a question of public policy and discuss possible solutions from different perspectives. All right, so in this case, the question that we're asking is, why can I grow lettuce for little to nothing in my classroom, but I can't afford it at the grocery store? Right, so this is what children are doing and what science can look like in their classrooms, right? And thinking about not just learning science for the sake of learning science, but learning science with a purpose. Being able to articulate to our community members issues that need to be addressed and that happen, that we can perhaps better articulate through a scientific lens or through some scientific language, but not because of the fact that we're taking learning science to pass a state test or learning science to pass any kind of an assessment for that matter, or as an entry point into college when we think about what happens once students end up taking standardized tests for college admissions, right? The knowledge that perhaps is visible to some and not to others. So if we think about science in these particular ways, we end up in this space where we can think about what it looks like rather than, again, us thinking about the limitations. What would science look like if we were to have or offer and teach it regularly in the classroom? There was a group that I sat with this morning that they have science, I believe it was 40, depending on grade bands, 40 minutes or so, twice a week, right? According to the national data, that is what, 4 classes of science in a week, right? So if we think about science in these ways that mean, rather than it being an add-on, but something that's central to, we can move to this space where we see that science is for everyone, right? It's something that we all use and engage with, right? And then as a result of that, we can also think about how our curriculum can then respond to this idea that science, again, is for everyone. We all use it to better understand our worlds. And in this particular case, this was a class that I was working with, a methods course of undergraduate students, where they decided, rather than us thinking about science first, what is the issue that's happening within the community that I can better understand through science? And as a teacher, how can I plan lessons around that? So in this case, they decided to focus on potholes because it was the middle of winter and that was something that they all had experience with coming to and from campus. However, there were questions that came up of why are there certain communities within a local proximity of the university that have more potholes than others? And what does that mean about the local community and where resources or how resources are allocated? So that was what they wanted to know more about. However, then thinking about fitting the standard, if you will, around that idea or around that wondering, then they were thinking about a kindergarten engineering standard or earth science standard, I'm sorry. So thinking about the fact that we can think of ways in which we reduce our impact on the environment. And again, this is within the scope, in this particular case, within the scope of a kindergarten classroom. Right, so I'm showing these examples because of the fact that it isn't to show, again, what isn't possible, but these are things that are already happening and things that we can encourage others to engage in as well, specifically as we think about those words from the beginning of the talk where you think about wonder, right, or joy, and what it means to engage in science learning in the classroom. So in thinking about that, there are, going back to the same report that I mentioned moments ago, there are recommendations that are offered for, again, various stakeholders, right? So in this particular case, stakeholders that are for state policymakers, for example. So one of the recommendations for that particular group and area is to think about establishing policies that ensure that science and engineering are comprehensively taught and frequently taught, and that during science and engineering time, students aren't pulled out for remediation in other subject areas, right? So thinking about what that looks like in policy is really important. right? So our second recommendation is for our district and school leaders, right? So examining the amount of time and resources allocated to science and engineering instruction, right? If there are little to no resources being allocated to these subjects, how can I reallocate materials so that materials and resources so that we shift that focus? And in doing that, I certainly would argue that the other areas that we tend to see or expect there to be, if rather than us expecting there to be a quote unquote dip in their reading or literacy or math proficiency, we should see those scores. If we're thinking about tests specifically as a standard of measure, we should see those scores improve, right, because of these efforts. Our third recommendation is for preschool and elementary school leaders. Perhaps going back to the question that I asked, the second question with regards to observing science in your building, right? So evaluating the characteristics of classroom instruction. So in some ways, a checklist isn't enough for me to go into a space and then see all that students are doing. Going back to the slides that I just showed, how is it that I would know to observe for those things as an administrator? How would I know that children are doing all of those wonderful things, right? So also thinking about the fact that the children that we're serving, again, from an identity perspective, don't match the demographics of the teachers that are teaching them. So as school leaders or as a school leader, how can I ensure that I'm hiring teachers that better mirror the demographics of the school that I'm serving or that I'm leading, and not just hiring those individuals, but supporting and retaining them as well, right? Because we see, especially in this particular phase, teacher burnout is real, right? I mean, folks will teach or can't feel the need to teach for a couple of years and then are on to something else not because of the children, but because of all of these external factors. And so thinking about that as a school leader is really important. And then lastly, state leaders, district leaders, and researchers. And so many of us in this room now are in one or maybe multiple of those buckets, right? So in thinking about that, us working together to build connections across preschool and elementary school, but also conducting research to think about what is actually happening, how are these things being taken up within the space? How is it impacting scores? Again, if we're using test scores as a metric, how is it impacting scores across other areas so that we then have data to provide to those that perhaps prioritize that type of information so that we can better or to prove our case, right? So lastly, at the individual classroom level, right, school leaders are tasked with supporting teachers, right? And teachers are tasked with supporting children. So one of the things that I also want to leave with you is thinking about how is it that we can support teachers in teaching or supporting the entire child. And so this particular diagram over on the right, I'm happy to share more information about, but it's referred to as the holistic science pedagogy. And so this idea that teachers are, if they make these 5 commitments, they can better meet the needs of children because they support, again, the entire child and not just supporting them in science or in literacy. But for example, one of the commitments is a commitment to ever developing self-awareness. Another commitment is to science and its practices. Another commitment is to science as a transformative agent, going back to science as being part of justice movements. Right? Another one is a commitment to students' social and emotional wellness. So what does that have to do with science? It has everything to do with science, right? Because this is the child that is engaging in, or I'm expecting to engage in, science learning. And if for some reason they aren't appearing as though they're engaged, there has to be something else that's happening. And for me, as a teacher, committing to better understanding that helps me better meet the needs of that child, right? And then lastly, a commitment to restorative practices. And so thinking about all of these things together and shifting, going back to the word cloud from the beginning, It's not just enough for us to just list or name words that we think about when we hear the word science, but what are the things that go into making perhaps those words a reality for children, right? So the parting thoughts that I'll leave with you are a couple of things. If you take nothing else from my time with you this morning, children are entitled to learn science at school, not at museums or during camps in the summer, but at school. Those other things are great as an add-on, but they shouldn't be the only thing, right? So to do this, we have to think about removing barriers for teachers accessing science instruction, whether that is going back to professional learning or confidence in teaching across subjects, any of those things. We have to be mindful of that, but also to develop a clear vision for science teaching and learning within your building and or district or whatever your context may be, right? We all have these spheres of influence. Whatever your sphere is, where you have the most influence, what does your vision of science look like within that sphere, right? And so you'll have some time to kind of wrestle with and think about that, but I also want you to think about from your respective roles, what does your vision for equitable science and teaching and learning look like, but also not just visioning these things, but why this particular vision? And perhaps more importantly, what is it that you need to be able to successfully enact this vision? Right? So not just, again, thinking about things in the abstract, but trying to make those things more tangible and going from there to thinking about next steps, right? So I'll leave you with that. I think I have like 1 minute for questions, but I'll also be around for the rest of the afternoon if there are questions that come up. Thank you so much. Yes.
I don't have really a question, but that was excellent. But I want your slides.
Yeah.
So can you share them? I don't know if anybody else, but I know that in speaking to the district leaders within my district, having those slides and really explaining and breaking down what it is that we need to make sure that science is successful within the district would make a world of a difference for them to actually see some of this stuff. So.
Yeah, I'm happy to do that. Thank you.
The slides will be in your that link at the end of the day, so you will have them. Mm-hmm. Any other questions?
All right. Thank you. Was there?
Go ahead. Was there another question?
All right. Thank you.